Hello, Miss Thinker here, your daily source for mind-blowing facts, forgotten history, and powerful motivation. Today, I will talk about why space is silent. Did you know space is completely silent? No explosions, no roaring engines, no screaming sounds. Movies make space seem loud and dramatic, but in reality, the universe is eerily quiet. So why is space silent? And if there's no sound, how do astronauts communicate? Today, we're diving into the surprising science behind one of the biggest misconceptions about space. Sound is actually vibration. When you hear something, music, voices, thunder, what you really hearing are tiny vibrations traveling through air until they reach your ears. Sound must travel through something: air, water, metal, solids. But space is a vacuum, meaning it has almost no particles at all. No air, no medium. No way for sound waves to travel. But what is a vacuum, really? It's a space where there are almost no particles. Space isn't a perfect vacuum, though. The vast regions between stars contain a few hydrogen atoms per cubic centimeter. To put that in perspective, the air you're breathing now has about 25 quintillion molecules in that same cubic centimeter. This extreme emptiness is what makes space the ultimate insulator for sound. There's simply nothing for the sound waves to push against. So even if two giant asteroids smashed together right beside you, you wouldn't hear a thing. To understand the silence, we need to know there are two main types of waves in physics: mechanical and electromagnetic. Sound is a mechanical wave. Think of it like a line of dominoes. The first domino has to physically hit the next one to pass on the energy. In the same way, sound waves need to push molecules together to travel. They need a medium air, water, or solids to act as those dominoes. But light and radio waves are different. They are electromagnetic waves. They are self-propagating ripples in electric and magnetic fields. They don't need to push on anything to travel. They can move through the complete emptiness of a vacuum. This is the fundamental reason space is silent but not dark. Light can cross the void, but sound cannot. Let's imagine you're floating outside a spacecraft. You see engines firing. You see metal creaking, you see objects colliding. But you hear nothing, total silence. Not because your ears stopped working, but because there's literally no sound reaching them. It would feel like watching a movie on mute. This is one of the strangest things astronauts experience during spacewalks near the International Space Station. Outside the station, no sound, no wind, no echoes, just silence. If space has no sound, how do astronauts communicate? They use radios. Radios don't rely on sound waves. They use radio waves, which are a form of electromagnetic radiation. Unlike sound, radio waves can travel through a vacuum. That's how astronauts talk to mission control and each other during missions run by NASA. Inside their helmets are microphones and speakers that transmit voices as radio signals. So while space itself is silent, astronauts are never truly alone. Many films portray space with loud explosions and dramatic sound effects. Take movies like Alien or other space blockbusters, they often include booming sounds for excitement. But scientifically speaking, those sounds wouldn't exist. Directors add them because silence can feel strange or less exciting for audiences. Ironically, the real sound of space would be far more unsettling: absolute silence. Humans evolved on Earth, surrounded by sound. Our brains rely on audio cues for safety: footsteps behind us, thunder in the distance, animals moving nearby. Sound tells us what we can't see. In space, you lose that sense entirely. No audio warnings, no background noise, no natural soundscape. Just visual information. For many astronauts, that silence feels both peaceful and deeply eerie. Technically, space is silent to human ears, but that doesn't mean it's completely inactive. Space is filled with radiation, magnetic waves, plasma vibrations. Scientists can detect these using instruments and convert them into audio signals humans can hear. For example, spacecraft like Voyager 1 record plasma waves in deep space. When scientists translate those signals into sound, they create strange cosmic noises that reveal what's happening far beyond Earth. So space isn't truly silent, it's just silent to us. One of the most significant forms of this cosmic noise is the cosmic microwave background, or CMB. Think of it as the leftover heat from the Big Bang, a faint afterglow that fills the entire universe. It's like the faint static or hiss you might see on an old, untuned television. A small part of that interference is actually the CMB. This radiation is the oldest light in the universe, dating back to just 380,000 years after the Big Bang. By studying it, scientists can learn about the universe's birth and evolution. It's like a baby picture of our cosmos. So the universe is constantly whispering the story of its own creation, not in sound, but in ancient light. Another silent marvel is the neutron star, the incredibly dense core left behind after a massive star goes supernova. Some of these neutron stars are pulsars, spinning hundreds of times a second. As they spin, they shoot out beams of radiation from their poles. If one of these beams sweeps past Earth, our radio telescopes detect a regular pulse. It's like a cosmic lighthouse, a steady beat in the silent darkness. These pulses are so precise they rival atomic clocks. Once again, it's not sound, but a powerful, rhythmic signal traveling across the void, telling us about some of the most extreme objects in the universe. But what about other planets? Do they have sound? Let's take Mars. But Mars isn't the only planet with a voice. Thanks to data sonification, we can listen to the entire solar system. Let's take a tour. Mercury, closest to the Sun, sounds like a strange distorted echo, a result of its magnetic field being buffeted by solar winds. Venus, shrouded in thick clouds, has a deep humming drone, reflecting its dense, oppressive atmosphere. Jupiter, the gas giant, crackles and whistles with the sound of powerful lightning storms and intense radiation belts. Saturn offers a chorus of eerie, shifting tones created by the complex interactions between its rings and its magnetic field. Uranus, the tilted ice giant, has a light, airy sound like a gentle, whistling wind from its thin rings and moons. And Neptune, the farthest planet, sings a haunting melody of high-pitched chirps and whistles, the sound of its own distant auroras. Each planet has a unique voice, a silent song telling the story of its own alien environment. Unlike the vacuum of space, Mars has an atmosphere, but it's over 100 times thinner than Earth's. So what would you hear? Thanks to NASA's Perseverance rover, we don't have to guess. The rover's microphones have captured the first ever sounds from the Martian surface. On Mars, sounds are much quieter and more muffled. A loud noise on Earth would be just a faint whisper there. High-pitched sounds are absorbed by the thin carbon dioxide atmosphere, so you mostly hear low-pitched rumbles. So while Mars isn't completely silent, its soundscape is a ghostly, muted version of our own. The silence of space teaches us something profound. Sound is not universal, it's local. What we hear on Earth depends entirely on our atmosphere. Remove the atmosphere and the entire soundscape of reality disappears. That means the loudest explosion in the universe could happen right beside you, and you'd experience it as a silent flash of light. So yes, space really is silent. Not because nothing happens there, but because sound has no way to travel. It's one of the most fascinating truths about the universe. Out there, beyond our atmosphere, the cosmos performs its greatest events in total silence. No noise, no echoes. Just the quiet of infinity. Would you rather visit space and experience total silence or stay on Earth with sound? Tell me in the comments.